Hello, I'm Maria Eugenia Moreira Garlac, Professor of Civil Engineering at Princeton University. Welcome to the Art of Structural Engineering Vaults. Before beginning the first lecture on vaulted structures, I want to provide you with some context and introduce the course themes and objectives. This course is essentially about civil engineering, and in particular, a subset of civil called structural engineering. But what is civil engineering? According to the American Society of Civil Engineering, abbreviated ASCE, quote, civil engineers design, build, and maintain the foundation for our modern society. That is a pretty big task. David Billington gives civil engineering the same importance in his seminal book, The Tower and the Bridge, published in 1983, where he writes, quote, civilization is civil works, and insofar as these deteriorate, so does society. ASCE continues to define civil engineering as a profession that designs, quote, our roads and bridges, drinking water and energy systems, seaports and airports, and the infrastructure for a cleaner environment, to name just a few. Civil engineers are more relevant today than ever. For example, consider that over 70% of the world's population is expected to live in cities by the year 2050. We are also faced with limited natural resources, aging infrastructure, increase in load demands due to intense and heavy traffic and extreme weather, and natural and human-induced hazards such as earthquakes, hurricanes, and terrorist acts. Engineers must design our civil works with these considerations and typically within the context of severe financial constraints. There are many technical areas or subsets within civil engineering, and structural engineering is one of them. Structural engineers design, for example, bridges, buildings, and vaults, meaning long-spanning roof structures. This course is about vaults. A previous online course discussed bridges, and in the future, we will launch an online course on buildings. Vaulted structures often dominate the visual appearance of the structure. Therefore, elegance must be a consideration of design. The engineers featured in this course illustrate how the best technical design still leaves room for aesthetic choice. The constraints of efficiency and economy in design do not stymie their creativity. In fact, it will be shown how constraints often lead to iconic structures, innovative forms, and novel construction techniques. The foundation for this course is a scholarship of my colleague, Professor David P. Billington, who has defined post-industrial evolution structures that are efficient, economical, and elegant as a new art form called structural art. Structural art has three ideals, and each of these can be related to ideals of the built urban environment. Efficiency is the conservation of natural resources. Economy is the conservation of public resources. Elegance is the creation of an attractive urban environment. Efficiency and economy can be considered the ethic of the engineer, and elegance the art of the engineer. Each of these three ideals can be mapped to a dimension or perspective that can be used for measuring structural art. The scientific dimension is measured by efficiency. It is based on calculations that reveal quantitatively the efficiency of form and the quantity of material used. This measurement is done with consideration of achieving adequate levels of safety. The social dimension is measured by economy. These large built works must be supported through public taxation or private commerce, both of which are influenced by the societal context, including politics. The symbolic dimension is measured by elegance. Here, the measure is mostly subjective. However, artists, such as painters and poets, are sometimes stimulated by these large utilitarian objects. We can also examine how society embraces such works, many of which become not only an icon of the city, but of the country. In structural art, the forms for bridges, buildings, and long-span roof structures come from the creative imagination of the engineer. The structural artists that we speak of, such as Pier Luigi Nervi, Eduardo Torroja, Félix Candela, Heinz Isler, and others, sought to integrate elegance into their forms. Beauty was not an afterthought. It was a conscious decision embedded in the process of design. The elegance derived by the form is based on engineering principles, not decoration, and elegance can be achieved without compromising efficiency and economy. Despite the discussion of elegance, I'm not talking about works of architecture in this course. I'm talking about works of engineering. There is a lot of confusion regarding the difference between engineering and architecture and their role in the design of structures. Both professions play very important roles and they work together. But what I am emphasizing in this course is that both architects and engineers have an opportunity to be creative in the design process. Engineers should not be looked upon as mere technicians in this process. In vaulted structures, such as domes and long-span roof coverings, both the forces and spaces must be controlled. Therefore, the final design benefits from the collaboration of both engineers and architects. Further, the vault must have proper form. It is essential. The consequences of not having proper form are dangerous at worst and expensive at best. One should not blindly, that is, without the discipline of engineering, design extravagant forms for vaults. The forms for vaulted structures highlighted in this course were given by the engineers who were disciplined by staying inside the boundaries of efficiency related to statics and calculations and economy related to construction. Yet these engineers recognize that inside of this space there is room to play, to find elegant forms. I believe that both engineers and architects should be educated so that they are adept at rapidly finding approximate dimensions using simple formulas. Further, they should study the development of structural forms and construction methods from times past to the present, and also learn to critique structures from both the technical and aesthetic point of view. This study of history and criticism is not common in engineering education. There is little interest in the recent history of engineering. Therefore, society tends to see engineering as the work of teams of technicians and committees of experts. In other words, the neglect of history and aesthetics in the education of the engineer has had the effect of dehumanizing and discrediting modern engineering. The importance of civil engineering in today's world and my intention of crediting the civil engineers for the value of their work and highlighting the role of structural engineers in the design of civil works are what have motivated me to teach this course. With a focus on vaults, I will illustrate 1. How engineering is a creative discipline and can become art. 2. The influence of the economic and societal context in vault design. And 3. The interplay between forces and form. I will use examples of real structures and real people to lead you through the fundamental principles of structural engineering and examine some of the best examples of vaulted design. In the short time frame that I have, it's not possible to include all important vaults and important engineers in this course. Please read The Tower and the Bridge by David Billington to gain a deeper historical perspective. This book was published in 1983, so to give it a more modern perspective, I end the course with contemporary vaults as just a small example of current times. One major theme that runs through each lecture is that engineering is a creative discipline. Engineering creativity requires courage to try new things, discipline to stay within the boundaries of rational forms that lead to efficiency and economy, and creativity also requires play to search for a proper form that is not only technically correct, but also elegant. The course has several learning objectives. By the end of this course, you will be able to 1. Recognize structural art, and for the important structures studied in this course, be able to identify the name of the structure and engineer who designed it. 2. Evaluate the success or not of a structure within the measures of structural art, meaning efficiency, economy, and elegance. And 3. Illustrate how economic, social, and cultural context influences the design of vaults. You will also learn about different vaulted forms, including domes, barrels, horizontal cantilevers, hyperbolic paraboloids, and non-geometric forms found by clever form-finding methods such as physical models and contemporary numerical tools. For each of these forms, you will develop an understanding of how the loads supported by the vault travel to the foundations. The course is designed for a general audience. No engineering background is needed. The teaching consists of lectures, which focus on social and symbolic, structural studies, which focus on scientific, and online questions. The brief structural studies, which are about 5 pages long, will guide you through some fundamental equations of statics and equilibrium to calculate the forces and stresses imposed on the vaulted structure. Course participants with stronger technical training may find the calculations in the assignments too simplistic, but these formulas are not watered-down versions of what engineers use today. They are the fundamental equations used by every engineer to analyze and design structures. To start our study of vaults, we need to travel to Germany. This is where the mathematical formulas defining classic vaulted forms, such as domes and barrels, were derived. In the first lecture on vaults, we study the German pioneers of vaulted structures, which include a man named Anton Tedesko. In summarizing his many years of experience with designing such structures, Tedesko stressed, quote, 3 important points on which depends the success of vaults. 1. Designers learn from having experience with full-scale structures. 2. Engineers should visualize the actual construction during the design stage. The economy of shells depends on the close collaboration of designer and builder. And 3, even in working with prestigious architects, the engineer must stand firm, making it clear as to what can be done and what should not be done. Keep watching to learn more about the German tradition of vaulted structures.